And welcome back. We are now going to look at a different kind of structure here, which is the stack and queue data structure. Now, when we start talking about stacks, these are a data structure that removes items in the reverse order of which they were inserted. A stack is a last in, first out data structure. That is, the data items are retrieved in the opposite order in which they were placed in the stack. So if you insert 1, then 2, then 3, and so on into a stack, and then remove them, they're going to come out in the order 3, then 2, then 1. We kind of briefly discussed this concept of stacks in Programming 2 when we talked about recursion, because it works in the same manner. It's going to put things onto the stack, and whatever's at the top will come off first. Now, a linked list is something that functions in this manner as well. It's going to insert and delete only at the head of that list, and that linked list, therefore, is in fact a stack because it's working the same way. We've seen this when, for example, when we've run our code and we put items onto a list, and then when we print them off, you'll see that that list is in reverse order. Now, the other thing to talk about is pushing and popping from a stack. So when we think about a stack data structure, a good way to think about this is it's like a stack of blocks, right? So every time we are making this tower of blocks, we're putting a new block onto the top of the stack to make a taller stack. And alternatively, if we wanted to take something off, well, we're going to pop the topmost block off the stack because, if we pull from the bottom, the whole thing would crumble down, right? So we're going to pull from the top until there's no more blocks to remove. And the way we do this is with the add to start method. And we kind of have been renaming this to really kind of reflect more of the stack terminology. Now, we will view a definition here in a moment of a stack class with a demo program that is based upon our linked list class. Similarly, the delete head node method has been renamed to pop and returns a string from the top of the stack. And although not shown here right now to keep our method simple, it would be appropriate to add other methods such as peek, clone, equals, and etc. in order to convert this class to be a generic data type. All right, right now we're pretty much looking at this with strings, but it wouldn't take much work for us to make it so we could use any class type. Now, the other thing to talk about is the queue data structure, which is kind of similar to what we have with stacks, but there's a slight variation. All right, with a queue, this is going to handle data as a first in, first out. So it's a little different than a stack. Stack is first in, last out. A queue is first in, first out. A queue, you can think about, it's like you're getting in line at the bank, or maybe you're going to a theme park or whatever. It's, whoever you get in that line first is going to be the first one to get on. In this example, if we're talking about bank, well, customers would add themselves to the back of the line and are served from the front of the line. A queue can be implemented also with a linked list. However, in order for us to do this, it needs a pointer both at the head of the list and at the tail or at the end of the list, because, well, you're doing action directly in both positions rather than simply just looking at one. Now, it's easier to remove a node from the head of a linked list than it is from the tail of a linked list, obviously, because with the tail, it's going to be changing position, so you have to kind of keep track of that. Now, when we look at the queue here, a simple implementation is going to remove nodes from the head list, and we can add nodes to the tail end or the back of the queue. And when we look at our example of a simple queue class in the demo program that's based upon our linked list, one thing you'll notice is that we did not make our queue a generic queue, all right? Because again, just like our stack, we're going to use strings here, and because it's going to be simple just to kind of demonstrate this concept. But again, we could, replace that data type with a type parameter to make it more of a generic class. Big thing to remember with queues, though, is that they are a first in, first out data structure. That is, the data items are removed from the queue in the same order that they were added to the queue. So again, remember, stack, first in, last out, a queue. And when we go ahead and look at our code here, here's our stack class right here. And you can see it is creating a node. So here's our node class. So we are effectively creating a linked list. And the way this works is we, of course, have our stack constructor. You can see we just set our head to null. And then every time we are pushing onto that stack, you can see we're simply just updating the head position. And then we're going to pop off the stack here. So we're just removing that. We're identifying the head to be, if it's null, obviously, then obviously we have a legal state. But otherwise, we're simply just going to update that pointer here. And this, again, very similar to like what we've seen with linked lists. Just now we're more calling it a stack, and you can see our terminologies have been updated. So here we have a pop. We have, of course, the ability to push. And if we look at this with our demo, you'll see we create a stack, and all we do is we push on the strings for that list, and we just test to see, okay, is this stack empty? Well, if it's not, let's go ahead and just start popping little items off that list. And of course, we could easily do this with other types. We could rewrite the stack class to, instead of this one being a string item, we could make this again, we could make it a generic class where we are passing in any type of class value. But if we look at with the queue, how that one is, you can see again, it's very similar to what we see before. However, we have a add to back method, which is going to allow us now to add items to the back of that list rather than simply just the front. And the way we do this, you can see we actually have another node here that we're kind of keeping track of it. And the way we do this, we say, okay, well, if the front of this is null, well, we're going to identify that to be the new back of that item. And then, of course, otherwise we have our back link is equal to new back. And so this node right here is going to be very helpful to say, hey, where are we putting this position? Otherwise, you can see it's very similar to what we might expect. We do have some other methods, for example, like who is next, which returns a string to the front of the queue, or remove front, which is going to remove a string from the front of the queue. And when we look at the queue demo, all right, how this works is that we're adding 3 people here. We add Tom, Rick, and Harriet, and we're simply going to add them to that list, and then what's going to happen is that we're going to then remove them from that list. So let's go ahead and take a look at these 2 demos in action. So let's start first with the queue. And when I run this one, you see it adds Tom, we have Rick, and then we have Harriet. So of course that's us printing out those. And then what we do is says the queue is empty because now they have been emptied out in that order. So first in, first out. If we look at the stack, however, all right, and we go ahead and run this list, all right, you'll notice Polly comes out first, whereas Billy comes out last. And so with this example here, one of the things you'll notice is that, again, it's first in, last. All right, so first to last, and this one is first to first. So again, a big difference here. First in, last out, first in, first out. But the stack and queue are going to be very important data structures as you start working with different data types and you have different things you want to process. And so, again, these are some very simple examples because we're looking at the ABCs of strings, but it wouldn't take that much for us to kind of rework these 2 different classes for queue and stack and turn them into a generic class that we could then